Okay, welcome to the second video here, which explores this idea of the basic trig functions a little bit further. Last time we explored the idea of sine of 30 being 1/2, cosine of 30 equaling root 3 over 2, and tangent of 30 equaling the square root of 3 over 3. But what about this? What if we talked about the sine of 60? Right? What if we switched from the 30 and started talking about the sine of 60? Well, when we switch angles, of course we switch what becomes adjacent and what becomes opposite. This becomes opposite, this becomes adjacent, the hypotenuse stays the same, but the sine of 60 will actually become opposite, which is square root of 3 over 2. The cosine of 60 would switch and become the adjacent, which is 1 over the hypotenuse 2. And tangent will switch, so it actually becomes the opposite, which is square root of 3 over the adjacent, which is now 1, which is just a square root of 3. So once we switch angles, we actually see that the relationship between opposite and adjacent switch. And we see a little relationship here between the cosine of 30 and the sine of 60, and the cosine of 60 and the sine of 30. They're actually equal to each other. And tangent of 30, tangent of 60 are actually reciprocals of each other. And we'll explore that relationship a little bit later. Right? But we're starting to develop our basic ideas for the most commonly referred to angles in trigonometry. And the last one we want to talk about here is going to be referring to a 45-45-90 triangle. So just one second. So you remember, right, if these angles are both 45, right, then what we're going to have are some very basic, let's call this 2. Well, this would be the same, right? So a squared plus b squared equals 2 squared, right? So we have, they're both x, so x squared plus x squared equals 4, or 2x squared equals 4, so x squared equals 2, so x equals square root of 2. So with that in mind, we can look at our sine of 45, our cosine of 45, and our tangent of 45. So again, if we're talking about 45-degree angles, it doesn't matter which one we're referring to because A and B are the same, right? They're going to be square root of 2. So sine is opposite of our hypotenuse, or square root of 2 over 2. Cosine is square root of 2 over 2. Tangent is square root of 2 over square root of 2, which is just going to be 1. And there are our most basic ideas for what we're going to do with our two special right triangles, our 30-60-90 and our 45-45-90 triangles. So these 9 numbers are going to be very important. And we're going to look at how to create this chart, right? So the way I like to write these out is a very basic chart here where we talk about sine, cosine, and tangent. And what's nice about this chart is you start to see some very nice patterns going on here. Now we actually are going to talk a little bit about 0 degrees and 90 degrees, even though those values actually will not make a right triangle. They do sort of start to make the pattern, which we'll look at when we look at the unit circle in future videos. So when we're talking about sine, right, we're going to assign this as a 0. Sine of 30, if you remember, was 1/2. Sine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And 90 will be 1. Now the interesting thing that I think here is that if you take a step back, right, notice that these three in the middle are all over the number 2, and then think about it in terms of this. Right? Square root of 0 over 2 is 0 over 2, which is 0. Square root of 1 is 1. Square root of 2, square root of 3, because they don't simplify. Square root of 4 is 2, so 2 over 2 is 1. So you see that pattern. Square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. So sine seems to increase as the angles increase to 90. Your angle, or your ratio, your sine ratio, will also increase. Cosine has the opposite effect, right? Cosine is 1, and then it goes square root of 3 to 2, because 30 and 60 are opposites of each other. These are both the same. Until we get down to 0. And then tangent, right? Tangent is really just your sine over cosine. Another way to think of tangent is sine over cosine, right? So 0 over 1, which is 0. Then we have 1/2 divided by root 3 over 2, right? 1/2 of that, we're going to get root 3 over 3. And then root 2 over 2, root 2 over 2, we end up with 1. And then the tangent of 60 is just the square root of 3. And then finally, which is 0, 1 over 0, is undefined. Tangent of 90 degrees is undefined because our denominator in this situation of sine over cosine being the same as tangent, you can't have 0 as a denominator, so that makes it undefined. So this is our basic table, and that should be enough to help you to get through each of the different sections, right? To be able to make this table and to be able to understand it, right? So sine, cosine, tangent. Sine counts up, cosine counts down, tangent follows sine. So if you notice, this is smaller. Here we have a root 3 over 3. Here we have a root 3. This is smaller till we get to 1, till we get to root 3, till we get to undefined. Tangent, I think, is maybe the hardest to memorize, but remember that tangent always follows sine, all right? And that should help you to remember it counts up as well, right? Okay, so try to memorize this chart as best you can. The next video, we'll kind of start to explore it a little bit more in relation to the unit circle, all right?